Hello learners, in this video we will learn about cloud workflows, a serverless orchestration engine, its core concepts, various features, and understand cloud workflows with a sample service orchestration use case. Okay, so what is cloud workflows? It's a service that lets you automate and orchestrate business processes across Google Cloud Platform and other services. It allows you to create visual workflows using a drag and drop interface without requiring any coding knowledge. With the workflows, you can streamline complex processes, reduce errors, and increase efficiency. The service provides integration with a range of Google Cloud services and third-party APIs, making it easy to build end-to-end workflows. Workflows also support error handling and retries, ensuring reliable execution of your business processes. Now, let's discuss the core concepts of Google Cloud Workflows. Google Cloud Workflows is based on the concept of defining and executing workflows. A workflow is a series of steps that are described using the workflow syntax, which can be written in either YAML or JSON. Once a workflow is created, it can be deployed, making it ready for execution. An execution is a single run of the logic contained in a workflow's definition. And a workflow that hasn't been executed generates no charges. Workflows can be executed using client libraries in Google Cloud Console, using the Google Cloud CLI, or by sending a request to the Workflows REST API. The product's rapid scaling allows for a high number of concurrent executions, and all workflow executions are independent. With workflows, you can easily create, deploy, and execute complex business processes without worrying about the underlying infrastructure. Now let's talk about each of the features of cloud workflows. The first one is redundancy and fault tolerance. Cloud workflows provides redundancy and fault tolerance, which means workflows are automatically replicated across multiple zones and checkpointed after each step, ensuring executions continue even after outages. It also has customizable retry policies, timeouts, and custom error handling to handle failures in other services. On the right hand side, you can see a sample workflow, how it looks and the syntax. Okay. I will talk about that in later slides. Okay. Now the next feature is self-documenting. Google Workflows or the cloud workflows is self-documenting, which means that workflows can be specified in YAML or JSON with named steps, making them easy to visualize, understand, and observe. These machine-readable formats support pragmatic generation and parsing of workflows. Now, the next feature is event-driven scheduled and programmatic triggers. Workflows can be triggered in real time or on a schedule. Through event arc, workflows can be executed when events occur, such as when a file is uploaded to cloud storage or when a pop-up message is published. HTTP callbacks. So workflows provide HTTP callbacks, allowing you to create unique callback URLs inside your workflows and wait with a configurable timeouts of up to 1 year for the URLs to be called, receiving the HTTP request data in your workflow. Workflow can wait for external systems and implement human in the loop process using these unique URLs or callback URLs. So the flow is going to wait for a human intervention, and once it is triggered by the another human or a manual process, then only the next steps are performed. Now, coming to security, workflows run in a secure sandbox environment and have no code dependencies that will require security patches, which means that you can trust that your workflows can be executed safely and securely. Additionally, you can store and retrieve secrets securely using Secret Manager, ensuring that sensitive information is kept confidential. A next feature is seamless authentication. With workflows, you can orchestrate the work of any Google Cloud product without worrying about authentication. Using a proper service account, Workflows takes care of authentication for you, so you can focus on building your workflows. Low latency execution. Workflows provide fast scheduling of workflow execution and transitions between steps. This means that your workflows will run quickly and efficiently, providing predictable performance with no cold starts. Talking about fast deploys, workflows can be deployed in seconds, providing a fast developer experience and allowing for quick production changes. This means that you can make changes to your workflows quickly and easily without having to worry about long deployment times. And the last feature is integrated logging and monitoring. Workflows provide out-of-the-box integration with cloud logging with automatic and custom entries that provide insight into each workflow execution. Additionally, monitoring tracks execution volumes, error rates, and execution time, providing you with a comprehensive view of your workflow's performance. Now, let's discuss about this sample workflow. Imagine you have a business that relies on the processing and analysis of various types of files from text documents to images and videos. With so much data to manage, it can be overwhelming to handle everything manually. That's where cloud workflows comes into the streamline your operations and save your time and effort. Let's take a closer look at a service orchestration use case that combines multiple services to perform a sequence of operations across multiple systems. Where you execute a cloud workflow, it triggers a cloud function and uh, it triggers a cloud function to check if a new file has been uploaded to cloud storage. If a file is detected, a cloud workflow starts performing a series of steps to analyze and process the file. The first step in the workflow is to streamline or determine the file type. If the file extension is .txt, the workflow integrates with the Cloud Natural Language API to perform natural language recognition or perform the sentiment analysis. This allows you to quickly and easily extract the important information from the text document, such as key phrases, sentiment analysis, and entity recognition. If the file extension is .jpg or PNG, the workflow communicates with the Cloud Vision API to recognize the new image. This feature allows you to automatically identify and classify objects, faces, landmarks, and other visual features in the image, providing valuable insight for the business. Finally, if the file is a video file with a .mpg or mpeg extension, video recognition is done through the Cloud Video Intelligence API. This enables you to automatically analyze and tag video content, including screen detection, shot changes, or object tracking. The last step in this workflow is to write tags into Firestore, a flexible, scalable NoSQL document database that makes it easy to store, sync, and query your data for your applications. This ensures that your data is organized and easily accessible, allowing you to make data-driven decisions with confidence. Overall, the cloud workflow offers an efficient and effective way to manage and process large amounts of data with the ability to combine multiple services and perform a sequence of operations uh, that you can automate the tedious and time-consuming tasks, allowing you to focus on what really matters growing your business. Okay, here are a few references that I have documented. So I have created a demo for a small demo to make a good understanding on the workflows, which you can find on this repo. And there are a few references where I have included some of the uh, GCP workflows articles on Medium, and these are the official documentations. Now let's look at a demo. Okay, so here in this use case or in this lab, we are going to actually uh, try to list down Wikipedia articles using the current date and time, and that is going to work through APIs. Okay, so let's take a look at this lab where we have to define some of these. So there are a few configs, Terraform configs. Now I have enabled services TF, provider TF, service accounts, variables, versions, and workflows. Let's have a look at them one by one. So default .tf is going to hold the default values that you are going to assign for this lab. Like in this case, we have project ID. So here, this is the project ID that I'm using for my uh, to run this lab. Now, then comes the enable services. Okay, second. Yeah, give me a second to load this lab first. Okay, great. So now if you see the enable services are going to enable some of these required services. Here we need to enable compute.googleapis.com APIs, service management and workflow execution, as well as we need to enable the services for workflow, The workflows.pf has the workflow details, what operation that we are going to perform. So if you see here, we are declaring a workflow service, and we are enabling the APIs. Here we are creating a sample workflow sample service account. Then this is the workflow that we are going to call or execute. So here we are going to get some of the HTTP APIs where it is going to retrieve the current date and time, and that current and date and time will be used to read from the Wikipedia APIs, and we are going to search for the articles based on the current date and time. Okay, we have to declare the dependencies or the versions for the Terraform that we are going to use, the Google provider details. We have defined some of the variables, the project ID, and the enable APIs as true. The service accounts are declared here, which will be used for executing these workflows. And in the providers, we have provided the backend. Now, when you try to execute this in your own environment, you have to edit this bucket name or create this bucket name in your environment before you execute it, or you can comment out all this code so that the state files are generated locally in your system where you are going to run this Terraform code. Okay, now let's execute these commands. So let me, yeah, so let's configure. Okay, so I'm going to set up the project where I'm going to deploy this component, change to the folder where the Terraform codes are present, and then initialize your Terraform. Also, validate if the configs look good. Now let's generate the plan. Okay, so no changes as I had already deployed these changes recently. So everything looks good. And I'm going to apply these changes. As the changes were already applied, let's see, we should not see any conflicts here. Okay. So as our workflow is already deployed, and we can list out the workflow that was deployed here. Okay, so gcloud workflows list. Here we can see we have a sample workflow deployed in the environment. Now let's execute this workflow to get our outputs or the result. So as you can see, this workflow name is sample.workflows. So I'm going to execute the same. Gcloud workflows execute sample workflow. Okay. Now the execution is done. Let's see the results once we describe this workflow. Okay, so if you see, here is our result. So when we executed this Terraform code and executed the um, the workflow, we can see the result. So these results are actually the Wikipedia articles with in relation with the current date and time. Okay, okay, let's move to the presentation back. Okay, okay. So to conclude, Google Cloud Workflows is a fully managed uh, it's a fully managed service that enables users to automate and orchestrate workflows across multiple Google Cloud services and, uh, and the external systems. It offers a graphical interface for designing workflows and supports the use of programming languages such as Python, JavaScript, and Java. Google Cloud Workflows also provides built-in connectors for common GCP services as well as the ability to integrate with external systems using REST and RPC APIs. Its features include error handling, retry mechanism, and logging capabilities. With Google Cloud Workflows, users can streamline and automate their business processes, increasing efficiency and productivity. Okay, so that is all about this, about the Google Cloud Workflows. Thanks for watching. Please like and subscribe to my YouTube channel to learn more about Google Cloud.